Well, Tony, that sounds almost too good to be true. I mean, why haven't we got these things on the roads already?
No, I run 2 electric cars and they're limited, of course, by the range. I mean, we've only got a speed of 75 miles an hour and a range of 100 miles. But if we could look to the future, and I'd like to look a little ahead, perhaps 10 or 15 years.
But when you, just a minute, you talk about electric cars and the limit in distance, you mean if you simply carry a pre-charged battery?
Yes.
But that's not what this technology is about, is it? You carry the hydrogen, which
yes.
essentially provides the fuel for the fuel cell. Yeah?
But the technology and the price of the fuel cell is yet unattainable to the average person. It will come down, as in fact wind energy prices have come down. But if we look forward to the future, and we think, well, all the cars have got a 60 kilowatt petrol engine in there. If we replace that with a 60 kilowatt electric motor, driven by a fuel cell, driven by hydrogen, the great benefit of that would be that the car would then be what you called a personal power station. When it was parked, it would receive hydrogen or town gas, North Sea gas on board, and it would deliver electricity and hot water. And this would mean that every car was a 60 kilowatt producer into the grid, into the home grid or into the office grid or into the shopping grid. And it would be credited with the electricity produced and costed with the gas put in. This would mean that the car was the cause of removal of pollution, because if you multiply the number of cars, 20 million, by 60 kilowatts, you find that the actual power stations running on fossil fuel are no longer needed.
I mean, this is fascinating, but how would you harvest the energy?
Do you mean to produce the hydrogen?
Yes.
Well, we've got the greatest source of hydrogen anywhere else in the oceans around us, H2O. And electrolysis of that is one means of separating it out.
But where do you get the power for the electrolysis?
Well,
electrolysis is splitting
yes.
water into hydrogen and
yes.
oxygen, yes?
Yes, you get.
But that consumes energy too.
Yes, it does.
So where does that come from?
At the moment, it would come from fossil fuel power stations.
Well,
but longer term, it would come from renewable energy sources, wind. And longer term from that, it would come from algae, and it would come from many, many sources. Hydropower, for example. Power stations have to go on half cock at night, and a hydro power station could continue all night long at full power, making liquid hydrogen fuel, which would be saleable at, I don't know what, £2 a gallon or something. So it would have a continual output. Given that we can produce the hydrogen, because we've got a tremendous access to hydrogen all around us, then once we've got that, we've got a personal power station that will power the whole of mankind without burning fossil fuel at all. But it's not now. It's in the future.
No.
You don't need to go straight to hydrogen. You can go to gas or another fuel. And the real costs in all of this at the moment is the fuel cell itself. And so what's needed is kind of volume manufacture of the fuel cell, which will bring that price down. And you can do that by going through the gas route. And then you can start coming in with hydrogen at a later date. So it would
Chris,
be
do you agree
renewable.
with that? Fuel cell's the way to go?
I think it's probably one of the things to be done. I think the key thing about electricity is that it can't be stored. And if you want a clean, non-polluting vehicle, power station or power source at home, it is electricity. The fundamental question is, where does that electricity come from? So we can go round and round in circles.
Yes.
At the end of the day, the only green power source is the so-called renewables, really wind, hydro, and probably biomass.
Well, let's move on to those. Let's look at each of them.